Now let's see some variations on the basic 2PL. So one variation is strict 2PL. So strict two-phase locking protocol. Now in the strict 2PL, it requires that in addition to locking being two-phase, all the exclusive mode locks taken by a transaction must be held until transaction commits. So what is the meaning of this one is, now if you observe this, so just show it here, I'll just try to explain you this. Now assume that there is a transaction Ti, right, and say there is a transaction Tj here. Now let us say there is a exclusive lock on A taken by Ti, and then it is going to write on A, right, and then this one is not going to release the lock until it is about to commit, right. So held until the commits, therefore only after it commits it is going to release the lock, right. Therefore it is going to commit and then release the lock on A. Let's say that is what is going to happen, right, or unlock A, right. Now what happens is, if any other transaction tries to read the value of A in middle, let us say Tj, if it tries to read the value of A by obtaining a shared lock on A, since the lock on A is already kept by Ti, it will never be granted to Tj. Therefore no transaction will be able to read data until, it is not just read, no transaction will be able to read or write data until the transaction which has written the data has committed. Therefore by doing this restriction, you are very sure that by doing this the schedule which is going to be generated is going to be strict. The reason is, if any other transaction has to read or write this data A, then it has to wait till this point, right. It has to wait until it commits, then only it is going to be unlocked, then only you are going to take it. Understood this? So what is the meaning of this one is, what is the difference between basic 2PL and the strict 2PL is, you are not going to release the exclusive locks until you are going to commit. Only after you commit you are going to release it. Therefore no transaction will be able to either read or write the data until the transaction which has written on it is going to be committed. So you can be sure that this is going to be recoverable, and this is going to be cascadeless, as well as this is going to be strict. See, it is definitely strict, and since it is strict, it is going to be cascadeless and recoverable. I have already shown you that the diagram goes like this. So the set of all recoverable schedules, and the set of all cascadeless schedules, and the set of all strict schedules, right. Now here, by having this rule, we are going to guarantee that every schedule is strict. Now if the schedule is strict, then it is already cascadeless and it is also recoverable. Why is it cascadeless? Since you are going to read the data only after this, there is no way you need to roll back if this one is going to be rolled back, because it is not going to roll back, right. If it is going to roll back, you will know it earlier only, right. So that is why there is no need of cascading, and also it is recoverable, because if it rolls back, then you need not do anything, isn't it, because you have not even started reading from it. Got it? Okay, that is why having this requirement, now having this requirement that unlocking is done only after this unlocking of exclusive locks is done only after the transaction is committed, is going to give us only strict schedules. Okay, so what are the things that you should remember is, here in this case only exclusive locks are going to be held, not all of them. So strict is going to hold only exclusive here in this case, until the transaction commits, all the locks. So the important point that you should be remembering here is all locks. Earlier only exclusive mode, but here all locks. So what does it mean? Even if you are taking a shared lock, don't release the shared lock also till you commit. Now what is the implication of this one is, if you are going to hold the shared lock also till you finish it, once you have read some value, no one will be able to write on that till you commit. But anyway, it is of no significance coming to the schedules, right? So it is not going to give us any special type of schedules. Whatever special type of schedules we should get, we already got from strict. So from strict 2PL, we got the we have got the schedules which are going to be strict. But making it even more stricter, which is nothing but rigorous, is not going to help us in any way, right? So even rigorous or strict, both are going to produce strict schedules only, right? And moreover, rigorous and strict both will have this deadlock problem. Okay, so there is no much advantage of strict, it is just proposed, but then to strict 2PL is as good as in practice, so we need not use any rigorous 2PL. Okay, next one is conservative 2PL. In conservative 2PL, what we try to do is we try to avoid the deadlocks. So how do we avoid deadlocks is, if a transaction, if it needs some locks, it has to obtain all the locks, then only it should start it, right? So I'll explain you what is happening. See, now earlier we have seen that in two-phase locking there is growing and then shrinking phase, right? Now in case of growing, here if a transaction has taken a lock and now if it is waiting for one more lock, then only there is going to be a deadlock, isn't it? Hold and wait is the condition. Now in this conservative protocol, what we are trying to do is we are completely going to eliminate this growing phase. So only because of the growing phase we are getting deadlock problem, isn't it? Only in this phase, if a transaction has obtained one lock and if it is waiting for other lock, it is getting some deadlock problem. Now if I completely eliminate this growing phase, then there will be only shrinking phase, right? Now when there is only shrinking phase, there will be no deadlock. The reason is, it is clearly saying that which requires the transaction to obtain all the locks before it starts and release all the locks after it commits. So which means before you start, you are going to take all the locks. Therefore the starting point itself is going to be shrinking point, right? You are going to get all the locks here and then you start releasing one by one. But then it is also not it is not going to release until it commits. So in the shrinking phase also it is directly going to release, it is not going to release one by one. Now what happens because of this one is, there is no hold and wait. So in this case, if you observe it, here such case will never arise. The reason is, if Ti wants A and B, it will request for A and B. If both of them are available, if it can get the lock on both of them, then Ti will start. And then Tj, when it tries to start, since Ti has already started, it will never get the access to these two data items, therefore it will get blocked. Got it? So only one transaction will start, after that other transaction will start. Now what is the disadvantage of this method? See this? Okay, let's talk about advantages. Advantages, there is no deadlock. And also, since it is going to release all the locks only after it commits, it is going to guarantee that the schedules are going to be strict. So no deadlock and the schedules are going to be strict. These are the advantages. Now what are the disadvantages? And one more thing, see, since the basic 2PL, it is going to guarantee the serializability. All of these are going to guarantee serializability, right? This one is going to guarantee serializable schedules as well as the schedules which are strict. But what is the disadvantage with this? There is a deadlock problem, right? Now what about this one? Same thing, serializable schedules as well as strict schedules, but the disadvantage is there is a deadlock. Now what about this one? Yes, again there is no deadlock, that is the advantage, and also serializable schedules and also strict schedules, right? But then there is a problem. The problem is that it is called conservative for a reason. So conservative because even though it requires some lock, let us say there is a transaction Ti, it requires lock on A now and a lock on B after a long time, let's say after 1 hour it requires lock on B. But then according to this conservative, we have to obtain both the locks, then only we are supposed to start. Therefore, we are unnecessarily holding a lock on B for a long time, right? So we are very conservative, and because of which all the other transactions which require access to B are going to be starved. Starved means they are going to wait for a long time, and because of which performance of the system might come down. Got it? So even though we have all the advantages, there is no deadlock, but still there is starvation. The performance of the system is going to come down because of our conservative approach. Got it? Okay.